Okay, so hey, this is Erin talking through problems 1, 2, 3, and 4 of quiz 3. So the first problem was asking about the fundamental frequency and then the frequency for the first three overtones of a pipe when you look at it closed at one end, open at the other, and then open at both ends. So you set up the equations with the same method, but since one is open on one end, closed on the other, you know that this is going to be the equation. Basically, is f of n equals n times the velocity over 4 of the lengths. So when you set that up, you can get the fundamental of which is just simply v over 4L. We have the velocity, we have L, so you can pull that out to get 157.4 hertz. 57.41 hertz to be exact. And then using this number, we can plug this in for the F1, the frequency 1, the original, and then here we're just multiplying it by 3, 5, and 7 because these are what we plug in for the ends. And we get these results. And so then we do the same thing for this second problem where the pipes open at both ends, although the setup of the equation is n times v over 2L instead of 4L because it's closed at both ends. And so, again, finding the fundamental frequency, we get 314.81 hertz, and then multiplying that through 2 times F1, 3 times F1, 4 times F1, basically just to find what these are. And then two small speakers. So they're in sync at 775 hertz, starting at 4.5 meters from the listener. A is slowly moved away, speaker A, and so we're supposed to find the three distances that produce three destructive interference sounds for the listener. So the way we find destructive interference is by taking the wavelength and divide it by 2 because it's half then, and that would be at the most destructive point because it's most amplified there. So first things first, find what the wavelength equals. And so we can plug into this equation v equals f times lambda, and we have these numbers, so we solve for lambda and we get 0.4387 meters. So going back in to plug it in for the first destructive interference, divide that lambda by 2 and we get 0.2194 meters, and then put this over and then to find the second destructive, we still need to do lambda divided by 2, but we multiply this by 3. This first time it was just multiplied by 1, which I didn't write in, but because that's the number of nodes, or not nodes, but like where you break the wave up to get it destructive. So it's like 1, 2, 3. I think that's the way to describe it. And then again, you do that 5 times lambda divided by 2. And these are what I got. And then for number 4, what are the first 3 distances that produce constructive interference? Well, the very first distance, where d is bigger than 0 meters. I wonder if this right here is just 0 meters, if it's just lambda. One wavelength. That's just one wavelength. So no, that's one wavelength away. Okay. 0 would be 0. Okay, one wavelength away is at 0.4387. We already solved for that meters away. You would have a constructive interference. Again, a second wavelength is just multiplying that by 2, and then our third is by 3. So that one was pretty simple. So it's at these points would you have constructive interference. Okay, that's all. Thanks. Bye.